In the previous video, I gave you an example of how to use double integral to work out an area. Now we're going to move from Cartesian into polar. So r equals 1 is this circle here, and then this thing here is given by this, and now we're going to work out this area here. So remember, in polar form, you start at an angle of 0 and then you move around like this. So you can see that as you move around, you start here, you start here and then you finish here. And then you increase the angle, you start here and then you finish here. 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 And then you come to a stop when the angle is at 90 degrees, pi over 2. So to use polar form, remember it's going to be r first. So it's going to be r equals something, r equals something. Well, if you look at this, hang on, you're moving around like this, and each time you start here, which will be r equals 1, and then you finish at this radius here, which will be 1 plus cos theta. So you start r equals 1 and then you finish at this radius here, which is given by this, and then you're scanning all the way through from an angle of 0, which is here, from an angle of 0, and then you finish at 90 degrees, which is pi over 2. So this area here, hang on, bear with me. So this area here, hang on, bear with me. So this area here is given by this. So now let's evaluate it. So evaluating it would give us, hang on. So now we've got to evaluate this. So we've got to look at the inner integral. So look at the inner one. This is your outer one. So looking at the inner integral, we've got to integrate it. We've got to integrate r with respect to r. So when you integrate r, it will give you r squared over 2. And then factor out the half. So a half is a constant, so you take it out here. So that would just give you r squared. So now we can put this into here, which will then give us this thing here. And then you take away, put the 1 into here. That will then give you this. And then now multiply this out. That will then give you this whole thing here, and this minus 1 stays the same. Tidy this up, so that will then give us this thing here. This thing here will stay the same. And then remember, for when we first started our integration, to integrate this, we would turn it into this block here. So now we can just integrate this block. So let's integrate this first with respect to theta. Integrate it, it will then give you this, and then integrate the half, that will give you theta over 2, and then integrate this thing here, that will give you sine 2 theta over 4. And we're doing it from 0 to 90 degrees, from 0 to 90 degrees. And then put this into here. Sine of 90 degrees is 1, so that will then give us this 2 here. Put this into here, that will then give us pi over 4. If you put this into here, it will be 0. Take away, put 0 into here, this will be 0. Put 0 into here, this would be 0. Put 0 into here, this would be 0. So that will then take us to here. So if you tidy this up, it will give you an area of 1 plus pi over 8. So this is our final answer. Okay.